In this question part, we have to find the derivative of fx. The differentiation here is relatively straightforward, but in my explanation I will take a bit longer and explain how the two rules that you see on the right-hand side apply here. The first rule that we'll use is for the derivative of x to the power of n from section 5.3 of the formula booklet. We are using this rule because x minus h is to the power of 2. As you can see, this rule tells us that the power comes down in front of x minus h, so for the derivative we can write negative 2 times x minus h. The rule also shows us that the power is reduced by 1, so we get x minus h to the power of 1. In the next step, we'll work with the chain rule because we have a composite function. This is so because x minus h is inside the brackets and it is squared. As I mentioned, we'll use the chain rule from section 5.6 of the formula booklet. The chain rule basically tells us that we have to multiply by the derivative of the inside function, and here the inside function is x minus h. The derivative of x is simply 1, and since h is a constant, its derivative is 0. Therefore the derivative of this inside function is 1, so here we'll multiply by 1. Finally, we have to differentiate 2k, and since 2k is also a constant, its derivative is 0. So for explanation's sake, I will add 0 here. From this then, we get that the derivative of fx is negative 2 times x minus h. Note that since this is only a 1-mark question, you don't have to show all the working out that I have shown here. To earn the mark, it is enough to write down the final answer. Let's see a quick exam taking tip. Most students remember that the derivative of any number is 0. However, when it comes to differentiating constants like h and k, mistakes happen more often, and many students, for example, get 2 when differentiating 2k. So just keep in mind that the derivative of any constant, even if it is denoted by one of the letters of the alphabet, is 0.